Hello, welcome back. Our next speaker is Jin Pang. Jin did his PhD at UC Berkeley AMP Lab, the same lab that produced Spark and Databricks. So please help me welcome Jin.
Thanks. Hi, my name is Gene Pang. I just want to thank you for coming to attend this talk, one of the last talks of the conference. I'll be talking about sort of some use cases with Spark and Tachyon, where Tachyon is an open source memory-centric distributed storage system. So I'll give you a little bit of background of who I am. My name is Gene Pang, and I just graduated recently from UC Berkeley in the AMP lab, which is the same lab that produced Spark and Mesos. And after I graduated, I joined Tachyon Nexus. So Tachyon Nexus is a company that started earlier this year. It was funded earlier this year. It consists of a lot of the top committers of Tachyon and also the creators of Tachyon. And the primary sort of focus for Tachyon Nexus right now is to really drive the development of the Tachyon open source project. And of course, like every other company at this conference, we're hiring. So here's our obligatory hiring slide. So here's the outline of my talk. First, I'll introduce sort of what Tachyon is, and then I'll talk about some of the use cases of Tachyon and Spark and sort of why you would want to use them together. Then I'll talk about some new features of Tachyon that have been recently released. And finally, I'll talk about how to get involved with Tachyon. So first, I'll introduce Tachyon. Here's the history of Tachyon. It was started in the AMP lab at UC Berkeley, and it was started in, so Haoyuan or HY started it in summer of 2012 as part of his research project. And this is the same lab that sort of produced Spark and Mesos over the years. So in 2013, HY open sourced the project, and after about 2.5 years, we just released version 0.8.0 last week. And so Tachyon has been getting a lot of momentum, and right now there are over 100 companies that have been deploying Tachyon. So here's sort of since this is an open source project, here's sort of an overview of sort of how the community has been growing. And so obviously when Tachyon started out in 2012, there was only one committer to Tachyon, and as the versions continue to progress, Tachyon's been getting so more and more contributors to the project. And actually now, just for the 0.8 release, there are now over 150 contributors representing over 50 companies. And so that's been really amazing and impressive to see with this project. And so just the project is only about 2 years old in open source, and it's one of the fastest growing big data open source projects out there. So it's really fun to be part of that. So of course, this is not possible without the contributors and users of Tachyon. So I'd like to thank a lot of the contributors and collaborators of Tachyon. Here are some of the individuals that have been contributing to Tachyon, and also some of the companies that they represent. And it's also really interesting to see some of the news and announcements that have been coming out about companies and people using Tachyon. And here are just some of the examples here. It's just encouraging to see how people are using it in ways that we haven't really had foreseen before. And so it's just really interesting to see how other people are finding new ways to use Tachyon in their systems. So you might be asking yourself, what is this thing called Tachyon? Well, it's an open source, memory-centric distributed storage system. And to get a sort of idea of how that fits in with everything, I'll show you a little picture. So Tachyon is sort of this layer that sits above existing storage systems that you may already have. And these include HDFS or S3. So you already have storage systems like that. Tachyon is a layer that's the memory-centric layer that sits above it. And it also is the layer that sits sort of below some frameworks that you already have that you're running today, such as Spark and MapReduce. And so Tachyon is sort of the memory-centric storage layer between your computation frameworks and your storage layer. So you might be asking yourself, why do I want to use Tachyon? Well, to answer that, there are sort of two trends that are happening today. First of all, memory is fast, and it's actually getting faster. However, the disk speeds and disk throughput is not increasing as fast. So in order to get fast access to your data, memory locality is very important. Also, here's another trend that memory is getting cheaper. And so here's a plot of sort of the cost per gigabyte of memory that you can buy. And as you can see, it's falling very steadily. And now it's actually very cheap for you to buy a lot of memory for your machines. And actually, a lot of companies are buying a lot of memory for their machines, for their servers. And it's much easier to get a lot of memory for machines on EC2 as well. So because of these two trends, memory is becoming more and more important for computing. And this is not a secret trend. People have already, and systems have already, taking advantage of this. Obviously Spark is, and there are other systems out there as well that are taking advantage of this trend of memory. So, maybe this problem's already solved because we already have systems that deal with memory. However, we think we're missing a solution that's a memory-centric solution for the storage layer. And so that's where we think Tachyon can really fit in. Tachyon tries to enable reliable data sharing at memory speed between different computation frameworks and jobs. And so this is sort of the overarching goal for Tachyon. And in order to do this, Tachyon has a lot of different techniques, but some of the main techniques are a memory-centric storage architecture for Tachyon, and also pushing down lineage down to the storage layer. So here's sort of a high-level view of Tachyon and its architecture. It's a distributed system made up of many nodes. There's a Tachyon master that essentially handles the metadata for the other nodes in the system, as well as the metadata for your data, which is organized in a file system manner. Also, there are Tachyon workers also in the system. And there are a lot of these workers, and they all sort of manage and expose and store their data in a RAM disk. And so whenever a client or application wants to access data in Tachyon, they're going to be accessing their data from the RAM disk of one of these workers. So their data will be in memory and can really speed up a lot of access. Also, Tachyon uses lineage in the storage system. In the same way that Spark uses lineage for RDDs, Tachyon uses lineage for files. And so here we have sort of an example pipeline of files and jobs that generate files. And say, for example, one of these files disappears or crashes. What Tachyon can do is it actually knows which files were used to generate that lost file. And so it'll actually recompute that file and sort of regenerate the file that was lost. And so this is one way to sort of to achieve sort of the fault tolerance in sort of a memory-centric storage system. So those two sort of techniques are some of the ways that Tachyon can achieve this memory speed shared data sharing. So now I'll move on to sort of how companies and people can use Spark and Tachyon together and why you'd want to do that. So obviously, we're all here because Spark is a very popular and it's a very fast-growing community around Spark, and it's a large-scale data processing engine. However, there are sometimes some potential issues you might run into while running Spark, and I'll talk about some of them and how Tachyon can help in those situations. So first, sharing data between different jobs can be a bottleneck because you have to sort of write data out to storage and then read it back in from the storage. So say in this example, we have 2 Spark jobs, and the second Spark job's input is actually the output of the first Spark job. So what has to happen is that the first job has to write data out to either HDFS or S3 or some storage system, and the second job has to sort of read it back in. And by the slow red arrows, you can see that might take a long time. And this is not actually isolated to Spark jobs only. It actually applies to other frameworks as well. So say the second job was a MapReduce job. Again, you would have to sort of write out the data to HDFS before reading it back in from the second job. So with Tachyon can help this and can solve this problem by providing memory speed data sharing between these two jobs, or between a sequence of jobs. And that is because the first job can write it directly to Tachyon, which is going to store all its data in the RAM disk, in memory, and then the next job can sort of read it from memory again without having to hit the slower hard drive-based storage. And so in this situation, Tachyon can really help a lot of sort of pipelined jobs that need to share data. Another potential issue is that if the computation crashes, you also lose some of the data that was cached in memory. And that's because they're sharing the same process. And so if one of your computation for some reason crashes, you lose all the data that was stored in memory again. So the next time you want to read that data, you have to read it from the storage that you have, and that could take a long time. So Tachyon can sort of solve this situation because it's a layer between the computation and the storage. So even if the computation crashes and you lose sort of that in-memory cache, the data is actually in Tachyon instead. And so by doing it this way, it sort of separates out sort of the computation and storage in terms of fault tolerance, and the data can still be read at memory speed for the next job that needs to read that same data. And also another issue that you might run into with running Spark is that you might be duplicating a lot of data in memory, and this also might cause sort of garbage collection pressure. And so in this example, we have sort of two Spark jobs that are reading maybe the same files, maybe the same blocks of the files, and they are both caching the same blocks in their memory, so sort of duplicated twice in memory. And so since memory is sort of a precious resource, you may not want to do that in your situation. So with Tachyon, you're not required to replicate your data per job that needs to read it. And so if you store it in Tachyon, you can avoid some of the unnecessary data duplication that you don't want. And also by doing so, you don't have to cache all that data in Spark. You can actually reduce some of that memory pressure that's in Spark, and that will also lead to sort of less garbage collection issues potentially. And so these are some of the issues that Tachyon can solve by running with Spark. And now I'll sort of talk about some of the production use cases that people are running both Spark and Tachyon with. Here is an example with Baidu. They're they're the dominant search engine in China, and they run Spark SQL to run a lot of their queries, and they actually store all their data in their sort of customized Baidu file system. And they run Tachyon in between Spark SQL and the Baidu file system, and they configure Tachyon to sort of manage both memory and hard drives. And they run a large cluster of Tachyon nodes, over 100 nodes. I think it's probably grown since 6 months ago. And Tachyon actually manages over a petabyte of space for their Tachyon deployment. And with this deployment, they actually got 30x speedups from before using Tachyon. And so it's a really cool use case where it speeds up a lot of their workloads. Here's another example of a company that uses Spark for their analytics and actually has all their data stored in GlusterFS. And so they use Tachyon configured just for memory, but they use Tachyon to sort of speed up their analytics on their data that they already have in GlusterFS. And lastly, there's another company that uses Spark and actually they use Spark to access data in S3. So they use Tachyon sort of in between Spark and S3, and they actually don't even use the memory tier of Tachyon. They only use SSDs, and this can actually cut down a lot of the network traffic that you might need to require to access S3, and also provide more locality in terms of the data. And so these are just some of the use cases that people are using, both Tachyon and Spark with together in order to improve their deployments. So now I'll sort of move on to sort of the new features of Tachyon that have been recently released. As I mentioned earlier, Tachyon 0.8.0 was just released, I think, late last week, and you can read more about it here at the Tachyon project website. So this first point is not a feature per se, but it's more of like an observation. So there's been sort of a growing ecosystem around Tachyon, and that's makes it really helpful to use Tachyon. There obviously are a lot of computation frameworks above Tachyon that can interface with Tachyon, and also there are a lot of storage systems below Tachyon that work with Tachyon as well. And so by sort of expanding this, I guess, the different types of frameworks and storage systems that Tachyon works well with, it really helps sort of drive the use cases and adoption of Tachyon. Secondly, Tachyon has a feature called tiered storage. And what this is it essentially allows Tachyon to manage more than just the memory of each worker. It actually, Tachyon enables managing SSDs and also hard drives of every worker. And this is sort of a good feature because memory, although it's the fastest type of storage that we have on most machines, it's also sort of the smallest capacity. And so by leveraging other types of storage such as SSDs and hard drives, you can sort of increase the capacity that Tachyon can manage. So related to tiered storage, Tachyon also allows you to configure the different types of tiered storage configurations for each worker. And here are just some examples of how you can configure it. You can configure Tachyon to only use memory, and so only use the memory tier of every worker. Or maybe you might configure Tachyon to use sort of memory and hard drives for the workers. Or maybe you just don't want to use memory at all and just want to use SSDs. And so Tachyon provides a way for you to configure how you want Tachyon to manage the storage. Also, related to tiered storage is Tachyon provides a pluggable data management policy. And this means that since we have different tiers and they have different characteristics, such as different speeds and different capacity, you might want data to be moved around between the different tiers in different ways, depending on depending on your workload. So, sort of at a high level, you might want some of the hot data or the data that you really want, sort of at the higher tiers, because you want to access that quickly, and you want sort of the stale data or old data sort of at lower tiers, because you may not want. May not be accessing that as frequently. And so Tachyon has sort of built in several policies, default policies that you can choose from. But if that's not enough, you can actually write your own policy that's customized for your workload, and since you know more about your workload. This is another feature, transparent naming, that's recently been added to Tachyon, and I think it's a really cool feature. This essentially allows a one-to-one mapping between the Tachyon namespace and sort of your under storage system namespace. And so before, in earlier versions of Tachyon, when you wrote a new file into Tachyon, it would write the file to under storage system, but it would sort of be in a special directory with a special name, and it's sort of hard to find where that file is. So now, when you sort of mount your under storage to Tachyon, the Tachyon paths are actually preserved. So it's really easy to find that file in Tachyon space and also in the under storage space. So in this example, we have sort of the Tachyon namespace to the left, and it's sort of exactly mirrored in the sort of the S3 sort of under storage system namespace on the right. Related to transparent naming is actually this feature called unified namespace. And this essentially allows you to mount different under storage systems in the Tachyon namespace. And this can be really powerful. It allows a lot of applications to sort of access data in different storage systems from the same namespace. It allows you to sort of share data between different storage systems from the same namespace. And so I think it's a really useful feature. I think it can enable a lot of new workloads. So in this example, we have sort of in the middle, we have the Tachyon namespace that has two folders, data and users, and sort of the root of Tachyon is mounted from some HDFS directory. And so the HDFS directory is sort of providing the users folder and users data. Whereas in the Tachyon namespace, the data folder is actually mounted from some S3 bucket. And so the data folder in Tachyon is actually being sort of mirrored by some S3 bucket in the Tachyon namespace. And so by sort of allowing multiple, being able to mount multiple storage systems in the same Tachyon namespace is a new feature in Tachyon. And there are actually, more features coming out in Tachyon. There's a remote write support where now you can write into Tachyon from anywhere. You don't have to be on a Tachyon worker. Now Tachyon can be deployed with Mesos and with Yarn. There's some initial security support in Tachyon, which sort of will enable more security features in the future. If you're not using Mesos or Yarn, there's a very easy way to deploy Tachyon on a cluster. And we also have metrics for clients and workers and the master. And so these are a lot of the new features that either have been recently released in Tachyon in 0.8.0 or some earlier version. So lastly, I will now talk a little bit about how you can get involved. As I mentioned earlier, there's sort of like a growing ecosystem around Tachyon, and there's a lot of new computation frameworks on top of Tachyon, and there's also a lot of storage systems that work with Tachyon below Tachyon. And so we're always welcoming new users and new collaborators for Tachyon, whether to use a new computation framework or to implement a new interface to a under-storage system, or just having new use cases. There's a lot of sort of room for growth with the project, a lot of new features that that we can add into Tachyon. And yeah, I think we're always welcoming new users and collaborators to the project. And so if you want to try out Tachyon, you can go to the Tachyon project website. You can check out our GitHub page and contribute contribute code back to Tachyon and look at sort of the source code there. We have a meetup. You can go to the meetup. Well, it's primarily it's in the Bay Area, but if you guys want to start up a meetup, in Europe or Amsterdam, that'd be great. We have the Tachyon Nexus website here, and my email is also up here as well. Thank you very much.
So we have time for 3 questions. Yes. I'll be back.
Hi there. Kind of on the issue of the transparent naming, is it possible to not have transparent naming? Like one of the concerns we have with running on S3 is we can't take advantage of the kind of sharded nature of S3 when using, say, Parquet tables, because everything ends up under a folder with the same name, and you don't kind of get the sharding. Could you use Tachyon to shard into the under storage bucket in a useful way to kind of leverage?
Oh, I see. So you're saying make it look like a single file, but it's backed by multiple files?
Or directory even,
or
but
directories?
yeah, but spread across multiple directories.
That's a good question. So right now, I don't think we support that, but I'll be willing to talk to you about sort of how you might want that to look like as a feature as a new feature in Tachyon.
Thank you. Hi. Could you talk more about the one-command cluster deployment or the easy deployment with using Mesos?
Yeah. So we have a command where you can deploy Tachyon on a cluster. So right now, I think it supports EC2 clusters, and so you can easily deploy. With one command, you can bring up a cluster of Tachyon in EC2,
okay, so
and this also works with. There's another command that you can run to deploy it with either Mesos or with Yarn.
okay, so it's all integrated as a script inside the package.
Excuse me?
It's integrated as a script inside the package.
It's a script inside the source code. Yes.
Okay, thank you.
Okay. One more question.
This might be a bit simple question, but just wanted to make sure of it. So when you run your Spark job on Tachyon, let's say Parquet file stored in Tachyon, does it take care? Does it use the locality, meaning that the worker executing the job is actually taking the file from its own memory, or is it actually shared and they're being shuffled around the network?
Yeah, so that's a good question. So Tachyon does provide a mechanism to sort of tell Spark like where the files are and sort of where the different parts of the files are. And so so we do make that information available. So the Spark scheduler can schedule Spark jobs on the machine that has it in memory already. And that's obviously going to be the fastest performance gains in that situation. So yes, that is definitely possible. And that's how it works.
All right. Thank you, Jean.
Thanks.
So we're going to meet back here at 5:10.